For our first section, we need to find all real and imaginary solutions of the following quadratic equations and make sure you show all your work. So for problem number 1, step 1, we have it set it equal to 0. Step 2 says we have to factor the left side. So I need to factor this. I'm going to use guess and check. So I have 1x times 3x, and that's the only choices to get to 3x squared. The choices to get to 10 are 1 times 10 and 2 times 5. Now because 10 is negative, we have one positive and one negative. So when if we're choosing 1 or 10 or 2 and 5, we need to make sure we have one of each. So off to the side here, I'm going to try my work here. I have to try 1x and 3x. That's the only choices I have. I like to put them vertically so that when I check the cross products, I can tell if it's the right one or not. Now I don't know what I'm going to choose, which one I should choose, 1 and 10 or 2 and 5. I usually start from the bottom, the two that are closer together, so I'll try 2 and 5. And when I cross multiply, I'm getting 6x and 5x. Can I use 6x and 5x when I multiply across to add to 13? No. With one of each sign, I can't add to 13. So before I abandon these numbers, let's try to rearrange them and put the 5 on top and the 2 on the bottom. And then if that doesn't work, then I know we can abandon the 2 and the 5. So when I do the cross products here, I'm getting 15x and 2x. Can I use 15x and 2x with one of each sign to get to negative 13x? I sure can. I put a negative on the 15 and a positive on the 2x, and that gets me negative 13x when I add them together. Once I have the signs correct, I can just slide them in. You do not need to use this method of factoring. You can use any method of factoring that you like, but this is just one I like. So I have x minus 5 and 3x plus 2. I write them horizontally, equals 0. Now I can set each of those factors equal to 0. So I have x equals 5. And negative 2/3. And that's my final answer. On our next problem, step 1 is we need to get it equal to 0. Well, it already is equal to 0, so that's good. Step 2 says to factor the left-hand side. I just don't think that's going to factor. Okay, so there is no numbers that multiply to 29 yet add to 4, and we can do it the shortcut method because a is equal to 1. Unfortunately on number 1 a was not equal to 1, so we had to use guess and check. So this is just not going to factor. Now I tried. I like trying to factor if I ever can. So I can't factor. So another method I could try is square root method. Well, this isn't a really good candidate for square root method either because we have a b term, and square root method is nice if it's already squared or if there's no b term, so we can easily isolate the square. So that's not going to work either. So my other two options are completing the square and quadratic formula. Either one of these is going to work. Completing the square is really nice because a is 1 and b is even, so this is going to work really nicely. Or you could use quadratic formula. Either way is going to work. Okay. I guess I'll use quadratic formula, but if you want to use completing the square, you can. So a is equal to 1, b is equal to negative 4, and c is equal to 29. And then I use the quadratic formula, which is negative b plus or minus the square root b squared minus 4ac all over 2a. So let's see. X equals negative b. Well, my b is already negative, so when I have the opposite of negative 4, that's really positive 4. And a lot of people would just go ahead and put positive 4 right there. I'll do it on the next step, but you could probably put just positive 4 there. Plus or minus the square root of b squared. Negative 4 squared is 16, so I'm just going to go ahead and write 16 right away. Minus 4 times a, which is 1, times c, which is positive 29, all over 2 times a, which is 1. So we have x equals positive 4 plus or minus Underneath the square root, we need to spend a little bit of time and effort there. I have to do PEMDAS, which says I need to multiply before I subtract. So I'm going to take 29 times 4, which is 116. So I have 16 minus 116. Now 16 minus 116, that's negative 100. So I have x equals 4 plus or minus the square root of negative 100 is 10i. Now this one isn't completely finished because 4, 10, and 2 all have a common factor. So if I factor out a 2 out of the numerator, I get 2 plus or minus 5i over 2, and then the 2 and the 2 can divide out, and my final answer is 2 plus or minus 5i. Now there is two answers here. There's 2 plus 5i, and then there's 2 minus 5i, which is where you get the two answers. Now, if you wanted to complete the square, you're still going to get the same answer, just you're going to have different work. Either way, you just got to show your work. For number 3, we have 4x minus 3 quantity squared minus 11 equals 0. Now, this one is set up as a very good candidate for square root method because we have the parentheses quantity squared, and there's no x outside the parentheses there. It would be very easy to get the parentheses all by itself by just adding 11. Now that the parentheses are by itself, I can take the square root of both sides, and that just gets me 4x minus 3 equals plus or minus. Anytime I take the square root of both sides, I have to take the plus or minus part, the square root of 11. Now, square root of 11 doesn't reduce. If it could reduce, you would need to do it, but in this case, 11 doesn't have any prime factors other than 1 in itself, so therefore 11 can't break down. Be careful, when you add 3 to both sides, the 3 and the plus and minus root 11 can't add because root 11 and 3 aren't like terms because one's under the radical and one's not. So we have 3 plus or minus root 11. Another common mistake is people will put the root 11 first and then the plus or minus 3. But clearly the plus or minus is attached to the square root of 11. So you need to put this plus or minus in front of the square root of 11. The easy way to do that is just to put the 3 in front, and that way the plus or minus will be right in front of the root 11. So the next thing we need to do is divide the entire side by 4. So I have x equals 3 plus or minus the square root of 11 over 4, which is a completely perfect answer, okay? But you could also split them up and write it 3/4 plus or minus root 11/4. Both of these answers are acceptable. You only need to put one, but just in case you were wondering, you could answer either one. On the next section, we're trying to identify if the following functions are odd functions, even functions, or neither. So odd functions are symmetric about the origin. Even functions are symmetric about the y-axis, and then neither would be, they're neither odd nor even, so therefore they're neither. Okay, so if we're talking about number 4, if I fold it along this line, and if you at home want to just take your paper and just fold it along the y-axis, is that symmetric about the y-axis? No, it's not, okay? So it can't be even. Some people will want to say, well, yeah, it's symmetric right here. Well, that's not the y-axis, so therefore it's not even. The next question is it symmetric about the origin, which is right here, which means if you fold it over the y-axis and then fold it over the x-axis, would you have symmetry? In this case, you don't. So we don't have any even or odd, so this is neither, or neither, depending on what part of the country you're from. Okay, the next function, if you fold it along the y-axis, this branch up here does not meet this branch down there. So therefore it can't be even. But if you fold it along the y-axis, the top will end up here. And then if you fold it again on the x-axis, this branch that we had folded is going to actually fold down here. So this branch and this branch So the orange part and the red part will match up if you fold it over the X and over the Y. So that means this one is odd. It might be a little bit easier to see if you just take your paper and fold it, that the orange branch will match up with the red branch if you fold it over both the X and the Y. And then the last one we have, if you fold it over the Y-axis, the branch on the left and the branch on the right will match up. So therefore this one is even.